Okay, for a second example, we have a parallel circuit here. So we're just going to mimic the given that we have from the series circuit. Okay, so for resistance, what we need is, for parallel circuit, for resistors, what we need is still the same. So we have total resistance, okay, and then total current. Then, of course, from what I've shown from one of the previous videos, so the voltages are equal for all of these resistors. So what we're going to look for instead are the current for each circuit. Okay, so since I've already said earlier that the formula of capacitance in series and parallel circuits is just the opposite of resistors, so that would mean this is 1 over RT is equal to 1 over R1 plus 1 over R2. Correct? Okay, so let's try to substitute that. And this time, what I want you to do is to show me the organic way of solving fractions, so I could see that you really understand it. Okay, so let's do that. So solution, I don't want you to immediately input the values on your cycle. Okay, so let's do that. So we have 1 over RT is equal to, what's our R1? 1 over 3 ohms plus 1 over 4 ohms. Okay, so to add fractions, first what we need to look for is the least common denominator, or the LCD. So let's try to look for that. So what's our LCD for this? So just multiply them. Okay, so that's easier. So this is 12, 3 times 4. Okay, 12 divided by 3. That's 4. 4 times 1 is 4. Okay. Next we have 12 divided by 4. That's 3. Times 1 is 3. Okay. So our 1 over RT is equal to 7 over 12. Okay. This is ohms. But since what we need is RT, not 1 over RT, what you're going to do is reciprocate, okay, or find the reciprocal. So that would be RT over 1. Oops, doesn't fit. Okay, let's move it here on the side. So that would be RT over 1 is equal to 12 over 7. Okay, now find the value of 12 over 7 on your cycle. So that would be 1.71. Okay, so our total resistance is 1.71. Unit is in ohms. Okay, you got that? So, okay, so let's write that here. 1.71 ohms. Okay, so I'm going to erase this now. Let's try to look for total current. So for that, what we need is Ohm's law is equal to IR. Right, so what we need is current, so that's I is equal to V over R. Substitute the value, so your V would be 14 volts divided by, what's our R sub T? This one, so that's 1.71 ohms. So our I current is, so divide that, 14 divided by 1.71. Is 8.187. What's our unit? Amps. So that's our total current. So try not to round this off first, alright? So 8.187. Okay, next, let's try to look for I sub 1. Okay, so for I sub 1, still the same formula, but instead of using total resistance, what we're going to use is R1. Okay, then same voltage, so that would be 14 volts divided by, what's our R1? 3 ohms. Okay, so our I1 is 14 divided by 3 is 4.67 or 4.67. Okay, so I'll write this one here. Okay, clear? Then let's do this for I sub 2. Okay, so this would be 4 ohms. Alright, so our I sub 2 is 14 divided by 4. So that would be 3.5. Unit is amps. Alright, so to check if we will be getting the total current, so what we finally need is this. Total current is I1 plus I2. Okay, so this would be I sub t is equal to 4.667 amps plus 3.5 amps. Okay, so let's see if it will match. If it's 4.667 plus 3.5. So what we found is 8.167. Okay. Unit is amps, which is a bit far but still close. Okay, to the total charge that we tried to look for earlier. Okay, so hopefully, as much as possible, what we're going to obtain on the hundredths place, so that would be the second place after the decimal point, would be the same. Alright, so as much as possible, try not to round the values of total resistance and total current to the hundredths place yet. Okay, try to retain at least 3 to 4 decimal places. Okay, that's it.